In this video, we will learn how to graph square root functions and cube root functions that have these horizontal stretches and compressions in them. All right, ones that have these numbers underneath the radical like this. And here's what it comes down to in the simplest way I can explain it. You guys know that if you see a number in the front, like a 2, the first thing we're going to do as far as the graph goes is we're going to make a new y column for that. And we would multiply by 2. So all you have to do is think of it this way. If we have a number on the inside, we're going to make a new x column. All right? We're going to make a new x column when this happens. But we're not going to just multiply by -3 to make the new x column. Because this -3, what kind of transformation is that, is the 3? That is a compression by 1/3. So guess what I'm actually going to multiply by? 1/3. Well, -1/3, okay, not 3. All right, so basically we'll make a new x column by multiplying by the reciprocal of this value. So that's what we're going to do. So first of all, the normal values that we always use, let's go ahead and fill those in. This is a square root function, so we will use 0, 1, 4, 9. And let's go ahead and put 16 as well. Since we're doing compressions and such, it might wind up fitting after all. I don't know why my 1 disappeared. So these are the usual x values. And the y values that go with them are 0, 1, 2, 3, and 4 as we just take all the square roots. Am I going to need a new y column on this problem?
No.
No, because there's no number in the very front. There's no a value. All right? I will call this a b value under here. So there's a b value, so I'm going to need a new x column. So let's just draw a line and make a new x column. And again, the new x column will take the reciprocal of this. So I'm going to multiply it. I'm going to do -1/3 times all the x's. Now, please understand that -1/3 x is the same thing as taking x and dividing by -3. All right, so my new x will be 0. -1/3 times 1 is still just -1/3. Now for the 4, again, I'm dividing by 3. So use your calculator, all right, a basic calculator. You won't be allowed to use your TI-30. But what's 4 divided by 3? It's 1.3, okay? So we're going to put -1.3. Okay? Now, of course, 9 divided by 3 is 3. So this will be just -3. So help me out. What's 16 divided by 3?
-5.3.
-5.3. So these are the new x values. All right? So I will go ahead and cross out the old x values because we're done with them. So these values will give us the skeleton. So I've got 0, 0, -1/3, all right, is just over a tiny little bit, and then up 1. -1.3 and 2. -3, 3. And -5.3, 4. Okay, so those are my skeleton values. So I haven't done the shifting yet. So what is the what is the 4 going to do for us?
Left 4.
All right, so this is left 4. And what? Down 2. So I'm just going to move all these points left 4 and down 2, and that's all there is to it. It's really quite simple. It's just a matter of making a new x column instead of making a new y column. That's all there is to it. Okay, so left 4 and down 2 would be here, and then I'm here, and I'm here. Okay? And that's our final answer. Oh, that's a miss. All right, any questions on number 1 so far? All right, so let's talk about the domain and range. What's the domain of this graph, you guys?
Negative infinity to negative 4.
Correct, so we're scanning it from left to right, so that's negative infinity to negative 4. What is the range going to be?
Negative 2 to infinity.
Correct, we're scanning from bottom to top, so that's negative 2 to infinity in that order. Okay, and the transformations. So what did that negative sign do? Right, the negative sign there is a reflection over the y-axis.
Wait, why is it negative infinity to 4?
Okay, so you're talking about the domain.
Yeah.
So looking at the domain, so I'm looking at the pink graph. So we go left to right for the domain, left to right. How far to the
Okay.
left? You see it?
Yeah. And then it'd be negative infinity to negative 2 for the range.
No, because range we do bottom to top. So what's the lowest value?
Oh, negative 2.
Negative 2, and what's the highest value?
Infinity.
Infinity. So negative 2 to infinity. Okay, so we have the reflection over the y-axis. And then what's the 3 going to do for us? Yeah, any number here underneath the radical, that's going to be a horizontal something, and it's the opposite of what it looks like. So that 3 is actually a horizontal compression, and that's why we say 1/3 by a factor of 1/3. Yeah, we did that part already. Hold on, Cersei, let me just write that down real quick, and then I got you. Horizontal compression by a factor of 1/3. All right, Cersei, you had a question. No, we're going to do the homework after this. Okay, and then of course we already talked about that. It's going to be left 4, down 2. All right, any questions? All right, let's practice that one more time. So this time we're dealing with cube root. So I'm dealing with -8, -1, 0, 1, and 8. And the cube roots of those will be -2, -1, 0, 1, and 2. And again, there's nothing in the front, so I'm not going to need a new y column. But because of this 1/4 on the inside, I'm going to need a new x column. Exactly. So to make the new x column, we multiply by the reciprocal of this b value. So the reciprocal of 1/4 is 4. So that's why I'm going to do 4x to make my new x column. So this is going to be -32. Say again? Yes. So when we do on the inside of the radical, we're making a new x column, versus on the outside of the radical, that's a new y column. Okay. So 4 times -1. So I've got -4 and 0 and +4 and +32. All right, so only 3 of these values are actually going to fit on my graph. So -4. So we can forget about the old x values. Okay, so I've got -4, -1, 0, 0, and +4, +1. And then we'll have to do our transformations. So this is right 1 up 3. Okay, so I'll just move everything right 1 and up 3. Right 1 up 3, right 1 up 3. And that's it.
Is that a vertical stretch?
No, this is a horizontal stretch by a factor of 4. Whoa, come back. Just erase my graph. All right, so your graph should look like that. So, of course, the domain and range are both -infinity to +infinity. All cube root functions have the same domain and range. And the transformations, we saw that we had a horizontal stretch by a factor of 4. And then we had right 1 up 3. Okay, when you look at number 3, am I going to need a new y column for number 3?
Yes.
Yes. All right, on number 3, I need a new y column because I have a number in front of that radical. Am I going to need a new x column? Yes, because of this negative is a -1. So I'm going to need a new y column and a new x column. We're going to need both. Okay? Ari, how we doing, buddy? All right, so we're going to need a new y column and a new x column. So for the new y column, we'll do 2 times the y's. For the new x column, what am I going to do? Right, -1 times x. Now don't forget, we are doing the reciprocal, but the reciprocal of -1 is still -1. All right, so my new, well, I guess I should have written down my original x's and y's. This is square root, so we're going to use our 0, 1, 4, 9, and 16. The square root of those are 0, 1, 2, 3, 4. So my new y values will be 0, 2, 4, 6, and 8. My new x values will be 0, -1, -4, -9, and -16. So since I have new x's and new y's, I will throw out all of my old x's and y's. Okay? So let's graph the skeleton. 0, 0, -1, 2, -4, 4, -9, 6. All right, and that's all that will fit. And then we'll do the additional transformation. What's this -2 going to do for us? Right 2. So I'm just going to move everything right 2. So boom, 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 boom. Okay, so your graph should look like that.
Yeah, arrows.
You can either take it all the way to the edge of the graph, or you can add arrows, or both. Okay, so what's the domain going to be?
2 infinity.
Nope.
-infinity 2.
Oh my
Do you
gosh.
understand why it's going to be negative infinity
No.
to 2, Savannah?
That's for another time.
That's for no, just remember, sweetie, when you look at the graph, you got to read it from left to right. Okay?
Yeah, but I have trouble. This is like sounds really stupid. I have
Mhm.
trouble with my infinities. Like I don't know
Like
how to
what-
read like negative infinity and infinity when it's
So just remember, so over here at negative 10, what kind of infinity is this over here?
negative infinity.
That's negative
So
infinity.
that's even if the arrow is pointing up or down, anywhere in the left.
Well, see, that's the thing. We have all of that. Okay? On the left, this is negative infinity. On the right, this is positive infinity. Now, up here, what kind of infinity is up here?
Positive.
Positive infinity.
Yeah, but that arrow is pointing positive.
That arrow is doing two things, okay? It's going left and up, okay? If I'm doing domain, I don't care about the up part, because domain is strictly the left-right thing,
Okay.
okay? When I'm doing range, range is bottom to top. So that's when I'll start looking about the fact that it goes up.
Okay.
All right, so for a domain, because it's left, that's negative infinity. But when I do range, it's up. That's why it's positive infinity for the range.
Okay.
Okay, so that domain was going to be, wrong color. So my domain is going to be negative infinity, comma, what was it? 2, positive 2. And so Savannah, what about the range?
Infinity to 0? 0?
Yes, but bottom to top.
0 to infinity.
0 to infinity. Because we're always doing least to greatest. So 0 to infinity. Okay, now the transformations.
Is it a vertical stretch?
It's because of the 2, that is a vertical stretch by a factor of 2. Okay, so write that down. Okay, and because of the negative 1 under the radical, what's that?
Horizontal compression.
No, because it's a 1, what happens when you multiply a number by 1? Does it get bigger or smaller? It stays the same. So because it's a 1, it's not going to get bigger or smaller, but
Stretch.
it's going to be reflection over the y-axis. James, head up, eyes open. So because it's a negative, there will be a reflection over the y-axis. Okay, and then right 2 because of the minus 2. All right, we'll have to stop there.
I think
All right, let's do one more problem. Again, we will need a new x column and a new y column. All right, we'll need a new y column because we have a number out front, and we'll need a new x column because we have a new multiplier in here, that's negative 1. So first of all, since this is cube root, we use the values of negative 8, negative 1, 0, 1, and 8. And we choose these values because they're numbers that we can take the cube root of easily. Okay, so when we do this y column, we're just doing the cube root of x right here. So that's going to give us negative 2, negative 1, 0, 1, and 2. All right, we always start off with that. Now, we will get our new y column, which I will do in green, by multiplying by this a value out front. So I will do negative 3y, and that will give us a new y column. So negative 3 times each of these. So negative 3 times negative 2, that's positive 6. and I'll have a positive 3 and 0. Negative 3 times 1 is negative 3. And negative 3 times 2 is negative 6. So these are my new y values. Now, to get my new x values, I multiply the x values, the old x values, by the reciprocal of this b value. Now, of course, the reciprocal of negative 1 is still negative 1. So I'm going to wind up doing negative 1 times all my x values, which just changes the sign. So this will be 8, 1, 0, negative 1, and negative 8. So these are my new x values and my new y values. So I'm going to go ahead and throw out the old ones. All right, and I'll be plotting these as my skeleton graph. So 8, 6 would be right here. 1, 3. All right, 0, 0. Negative 1, negative 3. And negative 8, negative 6. So this is my skeleton. I won't connect these yet because I haven't done my translation. This negative 2 that's not under the radical means down 2. Everything should be shifted down 2. So that is what I will do. So these pink points will be the points of the actual graph. So I'm just going to move every green point down 2. All right, so these pink points represent the actual graph. Okay, so your graph should look something like this. Hopefully even smoother. Got a little janky in here. All right, so that's how you do it. That's how you do a graph that has these horizontal, this is a reflection over the y-axis. In fact, yeah, let's go ahead and talk about the domain and range and all our transformations. So of course the domain and range are both negative infinity to positive infinity. Okay, because cube root functions go forever to the left and right, and they go forever down and up. So that's pretty simple. Now the transformations, okay, first of all, this negative sign in the very front gave us a reflection over the x-axis. So a negative sign in the very front is a reflection over the x-axis. Okay, now the 3, ignoring the negative sign for a second, this 3, because it's bigger than 1, that makes this a vertical stretch by a factor of 3. So any number out front is going to be a vertical something, and if it's bigger than 1, it is a stretch. If it had been less than 1, like 1/3, that would have been a compression. So we will say vertical stretch by a factor of 3. Okay. Now, this negative under the radical is also a reflection, but this is a reflection over the y-axis. All right? A negative in this position is a reflection over the y-axis. Okay, and finally the negative 2 on the end is a shift down 2. All right, and I'll just put it right here actually. Okay, so that's 4 transformations. And that is it for problem number 4.